Let's talk about how to calculate the volume of a composite solid. Remember that a composite just means that you're piecing together two different types of shapes, like how these two prisms were pieced together to make an L-shaped prism. The easiest way to calculate the volume of a composite is to break it down into more manageable pieces. For example, you could break it into a cube on top and a rectangular prism on the bottom. The volume of a cube is just length times width times height, so 10 times 10 times 10, or 1,000 cubic inches. And the volume of a rectangular prism, again, is length times width times height, or the area of the base times the height is another way to say that. So I have 32 times 10, which is 3,200. Add those two volumes together to get to the entire volume of 4,200 cubic inches. Our next composite can also be broken into a cube and a prism, but in this case it's a cube and a triangular prism. The volume of a prism is equal to the area of the base times the height. Remember that the base is not the side that it sits on. For a prism, the bases are the sides that are parallel and congruent. So this rectangle that it's sitting on is not the base. The base of this prism is the triangle, because there are two triangles. They are congruent and they are parallel, so they are the bases. The height of the prism is the distance connecting the bases, which will be 12. So our first order of business is to calculate the area of the base, or the area of this triangle. The triangle has a base of 12 and a height of 3. I'm getting 3 from the fact that the entire composite solid has a height of 15, but I know that the cube accounts for 12 of that, so the leftover 3 must be the height of the triangle. So the triangular prism's volume would be equal to 1/2 times 12 times 3, that's the area of the triangular base, times 12. That's the height of the base. And again, height does not have to be up and down. Height does not mean vertical. Height is the distance between the bases. So the volume of the triangular prism on the top of this composite would be 216 cubic meters. Then the volume of the cube is just 12 cubed. 12 times 12 times 12, which is 1728. So add those two volumes together to get to your total answer of 1,944 cubic meters. Our final composite is a combination of a cone on top and a cylinder on bottom. The volume of a cone is equal to 1/3 times the base times the height. Well, the base is a circle, and the radius of that circle is 3. But the height of the cone is currently unknown. We're given 5 as the slant height, and we'll have to use that with the radius to figure out the actual height, the perpendicular height. So using the Pythagorean theorem, 3 squared plus h squared, leg squared plus leg squared, is equal to 5 squared, which is the hypotenuse squared. So we find out that the height of this cone must be 4. So now we're ready to calculate the volume of the cone. The volume is equal to 1/3 the area of the base, which is pi r squared, times the height of the cone, which is 4. So the volume of the cone is about 37.7 cubic centimeters. The volume of a cylinder is equal to the area of the base times the height. The area of the base is pi r squared, so same starting point as what we had on the cone. We have the pi r squared again, and we'll multiply it by the height, which is also 4. We're just not using the 1/3 because a cylinder is the whole thing. A cone is only 1/3 of the volume of an equivalent cylinder. So the volume of the cylinder is 113.1 cubic centimeters, which means the total volume of this composite solid is 150.8 cubic centimeters. And that's all you need to know about calculating the volume of composite solids. That's all you need to know about volume and surface area in general. And actually, that's all you need to know about geometry. That's it. You finished the class. Congratulations! Next year, you're moving on to Algebra 2.